All right, so we'll finish up with our last conic section, which is hyperbolas. Okay, it's the last way we can slice a cone. And the picture is going to look very different from everything else we've drawn. It's actually going to be two separate pieces, the picture. But the definition is going to be extremely similar to an ellipse. Okay, so just as a reminder what an ellipse was. It's a collection of points in the plane such that the sum of the distances from two fixed points is a constant. So the sum of the distances from two fixed points is a constant. Yep, the only thing that you're going to change here is difference. So a hyperbola is a collection of points in the plane such that the difference from two fixed points is a constant. Okay, that's the only word that changes between the definition of an ellipse and a hyperbola. So the difference from two fixed points is a constant. And because that's the only thing we change, a lot of the formulas in the equation of a hyperbola is going to look almost identical to an ellipse, except we're just going to change one thing in the equation. Now, when we talked about an ellipse, these two fixed points had names. Does anybody remember what the two fixed points were called? They were the foci. Yep. And they're still called the foci here. Okay, I'll write that down in a second. But the two fixed points that we're measuring from are the foci. All right, so what I'm going to do is put up a picture of a hyperbola so we can kind of make sense of the definition a little bit. So the two fixed points in this picture are C and B. C and B are what we would call the foci. Okay, kind of like a parabola, the hyperbola wraps around the foci. Okay? Point E is a point that I can move on each branch of the hyperbola. Okay, I'm going to write that in a second, but these are called branches. Left branch, right branch. So if I measure the distance from point E to B, and then I measure the distance from point E to C and subtract it, I'm always going to get 5.66. And watch as I drag it. The two individual distances are changing. But that's actually doing the calculation. It's just always coming out the same. So if you subtract 9.69 and 4.03, you'll get 5.66. Okay? And that's true no matter where you move it.
So the distance between B and C is always going to be 5.66, right?
5.66 is the difference.
Yeah, it's the distance between, but so it would be the difference, the distance between the two.
It's not the distance from C to B. It's this distance minus that distance.
But if you put it so they're perfectly,
Oh, I know what you mean.
it technically would be the distance.
Well, the distance from E to C is about 7.9, and from E to B, it's about 2.3.
Yeah, but from B to C, it's 5.66.
No, because if you add the two, that doesn't equal 5.66.
Yeah, it won't equal
How do you
5.66.
subtract? Are you subtracting or adding?
You're subtracting.
Oh.
The whole thing about this is it's the difference.
It's a difference, yeah. Yeah, we'll actually never measure the distance between C and B. Maybe there's a name for that, the distance between the foci, but we never look at it. Okay? We just look at the difference between that blue line and that blue line, and it always comes out the same. Okay. That's how a hyperbola works. And there's two ways you can draw hyperbolas. Okay? This is where we'll talk about the name of the axis in a second, but this is where the branches open left and right. You can also have one where the branches open up and down. So this is like an ellipse in that there's only two cases. Okay? Unlike a parabola, there's four cases, up, down, left, and right. Okay? So there's only two. So those two fixed points in this picture that didn't move, C and B, those are your foci. Just like a parabola and just like an ellipse, the foci are not actually points on the hyperbola. They're points kind of inside it. If you draw a line right through the foci, kind of like what Luke was talking about, but if I also kept going, okay, right, just draw a line right through CB, that's called the transverse axis. So that's kind of taking the place of the term major and minor axis. Okay, we're using different names for the axes today. This is what would have been called the major axis in an ellipse. Okay, and the way I remember that it's transverse is, to me, transverse kind of looks like the word traverse. And traverse means to go across something. Like if you traverse the bridge, you go across it. And this is the axis that goes across the hyperbolas. Okay? It connects them. It goes across them. Okay, so that's how I remember it. It's the transverse axis. Okay, if you connect the two foci and find the midpoint, that's the center. This statement is the exact same thing I wrote down for an ellipse yesterday. Exactly the same thing. The midpoint of the segment connecting the foci is the center. Okay, the other axis, in an ellipse we would call it the minor axis. In a hyperbola we call it the conjugate axis. The conjugate axis goes right through the center and is perpendicular to the other axis. Okay, so if that's your hyperbola, if that's the center, that's the transverse axis, that's the conjugate axis. So conjugate axis goes right through the center, perpendicular to transverse axis. Okay. When you draw a hyperbola, it's always drawn in two parts. Okay. It's the only conic section that you have to, when you make a sketch, you draw it in two separate pieces. Each piece of the parabola is called, hyperbola is called a branch. Left branch, right branch. Top branch, bottom branch. Those are the only two ways you can draw, or that we're going to draw hyperbolas. Yeah. Technically, you can draw them a third way, but it's not something we do in this class, so we won't worry about it. Okay. The point where your transverse axis crosses each branch of the hyperbola, those are your vertices. Excuse me. Thank you. If it was drawn like this, that point and that point would be your vertices. And I think, yeah, that's most of the important stuff with a hyperbola. So a lot of the terms are the same. Vertices, foci. You still have axes, but we name them a little differently. And all the facts about A and C are going to be the same. And I'll write that down. A is still going to be from the distance from the center to the vertex. C is going to be the distance from the center to the focus. B, we use it, but we don't really talk as much about it. Not like we did with an ellipse. So, these are all the characteristics of a basic hyperbola. Center at the origin, no shifting. Okay. The foci. If you want to write this out, you can, or you can just write what we did yesterday. The foci are C units away from the center. That's how I would remember it. The vertices are A units away from the center. That's how I would remember it, rather than writing the coordinate, but it's up to you. And this is the case where everything lines up horizontal. If you graph your foci and vertices, they'll all line up in a horizontal line. So the transverse axis is horizontal. So looking at the equation, what's different about this equation? The only thing that's different is right here. That's a minus instead of a plus. Now, what about the formula on the right? What's different about this? It's a plus instead of a minus. Okay, it was a squared minus b squared for an ellipse. For a hyperbola, it's a squared plus b squared. Looks kind of like the Pythagorean theorem, but we're not really doing anything with triangles. So. Hey, any questions on that? Okay, now I want to show you, I'm going to give you a hint at how you can draw a hyperbola. Okay, relatively accurately. Okay. What I'm going to do is, do I already have one? Just looking for a picture already drawn, but I don't have one. So I'll draw it. Okay, so I'll come back to this page in a second, because next we're going to look at the case where the transverse axis is vertical. So it's just going to change two things around in that equation, and you can make the transverse axis vertical. Just switch two things. All right, but let's pretend like we had hyperbola. And I'm going to sketch it with the center at the origin. And it's going to do something like this. Okay, and to try to make this kind of accurate, I'm just going to make a mirror image of it and put it on the other side. Because that's all a hyperbola is. It's just a mirror image. Let's put that over here. Maybe about right there. Okay. So sometimes it's hard to figure out how wide are these branches supposed to be. Is it, you'll know your vertex, but should you make it like that, or like that, or should it even be wider? We have to kind of figure out the width of the branch. So I want to draw something and see if you recognize this. Let's go like this. What do you think I'm drawing right now? An asymptote. So this branch, if I try to draw it a little more accurately, is basically going to go like this. It's just going to get closer and closer and closer to that line. And this branch, if I try to draw it a little better, is going to go like this. It's just going to get closer and closer there. And there's also an asymptote in the other direction. So this branch just gets closer and closer to that. And this branch is going to get closer and closer to that. So that's, if we can figure out where those asymptotes go, it kind of gives you an area inside an X to draw your branches. Okay? And there's an easy way to figure out where the asymptotes go. They go right there. The equation of the asymptote is y equals, and it's positive b over ax. That's the slope of one of the asymptotes. And the slope of the other asymptote is negative b over ax. And what's the y-intercept on this equation? What's the y-intercept looking at that equation? Think of it as y equals mx plus b. 0. There is no y-intercept. So what does that mean about this line? Goes to the origin. Okay, when you're looking at the basic case of a hyperbola, and that's how I tried to sketch it here, the y-intercept is 0, so your asymptotes go right through the origin. Good. So there's one extra thing you have to find with a hyperbola. You have to find the asymptotes, and that's how you find it. You still use the same information you would have had to find anyway. You're just going to use it one extra time to do something else. so I wouldn't worry too much about that. Really, when we're graphing a parabola, if you find the asymptotes, that gives you enough information to sketch it. That's all you need to find. Draw the X shape, and you're good. So don't worry about that. This is summarizing the same information we had yesterday. Okay, A is the distance from the center to the vertex. And C is the distance from the center to the focus. And again, since it's a distance, we just want to make sure it's always positive.
Just look at the drawing, how do you know what the focus is?
How do you know what the focus is? They'll usually give you the focus. Or if they don't give you the focus, which is C, they would have to give you A and B. And then you could find C. But in general, the focus is what the branch of the hyperbola wraps around. So I'm just kind of estimating it, but the focus would probably be like right about here. It's what it would wrap around. But if you want to know the exact number, they got to give you the right information to find it. Okay, any questions on that? All right, so let's try this one. So for this one, we'll graph it, okay, just to make sure we can graph, but we won't graph all of them. So find the equation of the hyperbola and graph. Equation of a hyperbola is always equal to what number? 1. It's going to be 2 fractions. What goes between the 2 fractions? Minus sign. And for a second, I want to skip ahead to show you the equation when the transverse axis is vertical. I'm going to come back to it so you can copy it down, but I just want you to be able to compare this one to the other one, and then I'm going to ask you something. So this is the one where it's horizontal. Notice when it's horizontal, which letter is positive here? The X or the Y? The X. When it's horizontal, the X was the positive. Okay, let's look at when it's vertical. Which letter is positive now that it's vertical? The X or the Y? The Y. That's the positive one. So when we're dealing with a hyperbola, it's not where the bigger number is. That's an ellipse. You have to forget about that idea. A and B are always in the same spot. You never switch A and B. Okay, with an ellipse, we did, but not with a hyperbola. Keep A and B right where they are. A and B. A and B. What is it that switches in the fractions if it's not the A and the B? It's what? The X and the Y. Okay? That's what switches. So when you have a horizontal transverse axis, X is positive, and you put it first. When you have a vertical transverse axis, Y is first. Okay? So the only thing that switches in a hyperbola is the X and the Y, not the A and the B. That's what gets a little confusing between ellipses and hyperbolas. But if you write that down, then put it on your reference sheet, you'll be able to remember it. Okay, and I'm going to come back to this so you can copy it down. But let's try our problem. So if this was a problem on the test, it could be either type. Okay, it could be the horizontal or the vertical. Since up to this point in the notes, the only kind I've gone over is the horizontal, this is going to be the horizontal. So if we want the transverse axis to go horizontal, what letter goes horizontal? X or Y?
Y.
X. X is always your horizontal. So that means make X positive. Make the Y negative. Whichever letter you make positive, that will be the direction of the transverse axis. And I told you the transverse axis was going horizontal. Okay. Square. All right, now we need to figure out A and B. A squared is going to go here. B squared is going to go here in every single problem. So, how do I find A? It's the distance from what to what? Center to the vertex. A is 2. How do I get C? Oh, John?
It's going to be the center to the focus.
Center to the focus. Yep. Which is how much? 3. Now, I've got A and C, but in the equation, I really need B. What's the formula to find B? And just be careful you don't mix it up with an ellipse. C squared equals, yes, A squared plus B squared. So I made that mistake when we were going over a homework problem because it's easy to make. So 9 minus 4 gives me 5. So what's B? Square root of 5. So now just take what I just circled, plug them into that equation, and that's your answer. So we get x squared over 4 minus y squared over 5 equals 1. Okay, so we have our equation, and now I want to graph it. Okay. My hint to graphing it was to find the two what? Find the two asymptotes. So what I would do is look up on your reference sheet, what's the slope? In this version, it's b over a. So let's write our two asymptotes. So b is the square root of 5 over a is 2. Not the nicest number, and in fact, to graph it, I really need a decimal, so I'm going to round it off to 2.2. Okay, square root of 5 is about 2.2. The only reason I'm doing that is so when I do rise over run, I can count a little easier. So 2.2 over 2x, and what would be the other asymptote? Negative 2.2 over 2x. So remember slope, right? Rise over run. What's the y-intercept on both of them? 0. Okay, so I've actually already drawn them, but I need to go up 2.2 and then right 2. So up 2.2, right 2. Up 2.2, right 2. So I just did that. Okay. And then I also need to go down 2.2, right 2. Down 2.2, right 2. Just estimate 2.2. You know, if it's close, that's fine. Okay. So we have our X shape, and let's put in the vertex. Negative 2, 0. 1, 2. Now they didn't tell me the other vertex, but it has to be symmetrical. So where's the other one? 2, 0. And now draw your branches right through those points. Just try to stay close to the dotted line. So something like that. And can't see. Kind of like that. Good enough. Okay, so the asymptotes really help you with the width of the branch. Okay, as far as graphing, that's probably the only graph I'll do today. Okay, any questions on that? I think reference sheet, very helpful for this test. It's not really anything hard in terms of calculations, very basic arithmetic, but it's a lot of stuff to remember, lots of formulas. Okay, so make sure you put the charts on your reference sheet. All right, this one, we're just going to discuss it. So they've given us the equation. And the first thing you want to find is a and b. Where is a always in a hyperbola?
Under the X.
It's always, it's not always under the
Well, it's
x.
always the bigger number.
It might not always be the bigger number. That's only for an ellipse.
And I have no idea.
Where is a always? In this case, it's under the x, but it might not always be under the x.
It's numerator, always. Yeah, denominator, that's what
This, it's under the first, it's right here. Okay, a is always, it's like Bria just said, it's under the positive. Okay, a is always the first one, b squared is always the second one. Always, that never switches. In an ellipse, it does, but not here. So what's a? And b? 2. And now, they do want to know the foci, so I need c. So c squared equals a squared plus b squared. So what is square root of 20? So we got a, b, and c. Okay, let's do the center. Where's the center in this one?
between the two foci, right?
Yep, it's right between the foci. And where's the center always before we shift it?
Oh,
Okay.
yeah.
0, 0.
It's at 0, 0. You'll know when it's not 0, 0 because you're going to have an x minus h in the top or a y minus k, just like with an ellipse. Okay? There's nothing in the numerator. So the center is 0, 0. Which letter here is positive? X. So that means the transverse axis goes which way? It goes horizontal. It goes with the positive. So now when we start thinking where things are, they're going to be to the left and the right. That's horizontal, not up and down. So the vertices are how many units away from the center? Yeah?
2 units,
How many?
2 units away from the center, along the horizontal.
Nope, the vertices are not. What letter tells you A? A is the distance from the center to the vertices. So they're 4 units away from the center. Okay? So, and we're left and right because everything is horizontal. So, what would be 4 units to the left of 0, 0? Yep. And what would be 4 units to the right? You can sketch it if you need to see the symmetry. You could always do that. But they didn't say to, so we don't have to worry about it. Okay, what about the foci? What letter will help me find the foci? C. How many units away from the center of the foci? Not 20. Square root of 20. Okay? So the foci are C units away from the center. This one's going to look a little messy, but it's square root 20, 0, negative square root 20, 0. Okay, and the asymptotes. What was the slope? Was it A over B or B over A? This one is B over A, positive and negative. And this is going to be nice. What's B divided by A? 2 divided by 4? A half. So your asymptotes are positive a half and negative a half. So that's every single thing you could possibly describe about a hyperbola. Most problems don't ask you to describe every single thing. This one did. Okay. So any questions on that? Let's try same thing. Same thing again. What's going on here? It's not in the right form. What does it have to be in the right form? It's got to be equal to 1. Okay, so how do I get it equal to 1? Brad? 2 what? Yeah, divide by 36. Divide everything by 36. Right? 9 goes into 36. How many times? 4. 4 goes into 36. How many times? 9. And 36 goes into 36 once. There's our equation. Now we do exactly the same thing we did in the last one. What is A in this case? 2. Good. It's not always the bigger number. It's always the first denominator. What's B? 3. And C would be the square root of 4 plus 9. 13. Okay, that's everything we need. So this time, is my transverse axis horizontal or vertical?
Horizontal.
It's horizontal again because the x is positive. Okay, so I'm going to write horizontal. The center, where's the center unless we have some extra numbers in the numerator? It's always 0, 0. What letter helps me to find the vertices? A. So how many units away from the center are the vertices? 2. What's 2 units left of the center? 2 units to the right? Okay. Foci, what letter do we use for that? C. How many units away from the center of the foci? Square root of 13 to the left. Square root of 13 to the right. And my asymptotes, bless you, is what over what? B over A. 3 over 2, positive. 3 over 2, negative. And that's everything you could describe. Any questions on that one? So same as the last one, you just had to get it in the right form first. All right, so this I kind of already showed you. I really wouldn't worry about writing that stuff down. That stuff is I would remember it as the vertex is A units away from the center, the focus is C units away from the center. And that applies to everything we've done yesterday and today. This equation is exactly the same. C squared equals A squared plus B squared. Only difference between what's in this box and what we had before, X and Y switch places. A and B do not. So if you make the Y positive, now the Y is the vertical. So you just made your transverse axis vertical. So now the center, the foci will be above and below, and the vertices will be above and below. Everything's going to be vertical, not horizontal. Yep.
So for the foci and the vertices, you're just typically switching?
Yeah, the 0 is now the first coordinate instead of the second. That's what makes it vertical. Now, what was the slope of our asymptotes when it was the other way? It was B over A. This is A over B. And the way that I remember it, I just try to remember this. I don't know if it'll help you, Bab. When it's vertical, it's A over B. Bab. Vertical, A over B. When it's horizontal, it's Hyperbola. That doesn't really help as much. But Bab, vertical, A over B. Okay. Vertical, A over B. Bab. All right, so let's do the same thing we just did, except we'll do it with this equation. Okay, does everybody have that? If you have that, that's all you need. All right, so what's going on here? What do we got to do? First, you got to divide everything by 4. So we're going to get y squared over 4 minus x squared. I want to put a denominator just so I have something. What could I put? Put a 1 equals 1. Okay. What's a? 2. B? 1. And then c is the square root of a squared plus b squared, which is 5. That's all you need to figure out to answer the questions. All right, if there's nothing else added or subtracted in the numerator, where's your center? It's always at 0, 0. How about my vertices? Are they going to be above and below the center, or to the left and to the right? Above and below, because the y is positive. Okay, so everything is going to be vertical. So, where would the vertices be? What's 2 units above the center? 0, 2. And what's 2 units below? 0, negative 2. The foci are going to be square root of 5 units away from the center. So what would be the coordinates for that? 0, square root 5, negative square root 5. Asymptotes. What's the slope when it's vertical? Vertical is a over b. A is 2, b is 1. What's 2 divided by 1? 2. And make sure you do negative 2. Okay, that's everything you'd have to describe. Any questions on that one? It's not too bad once you start doing them, but it's just when you switch between different conic sections, then it starts to get confusing. But on the test, all the parabolas are together, then all the ellipses are together, then all the hyperbolas. So it's exactly in the order we studied. All right, let's try this one, and then I want to do one that's shifted, at least one. Let's set up our template for the equation. A squared always comes first. B squared comes second. Think about the foci. If you graph the point 0, negative 3, and 0, positive 3, would those line up horizontal, or would they line up vertical? Yeah, 0 down 3, 0 up 3. So if they're going to line up vertical, that means what letter has to be positive? The y. That's the equation you're using. So let's just find a and b. And we'll probably have to find c to do that. What's a in this case?
This is 6.
Well, a is the distance from the center to the vertex. Center is at the origin. The vertex is 2 units above it. So a is 2. What about c? 3. It's the distance from the center to the focus. It doesn't matter which focus. It's going to be the same. That's 3 units above the center. So it's 3 units away. And now b, c squared equals a squared. B squared, this number's come up a lot today. B is going to be square root of what? Square root of 5. Okay, so now fill in those 2 numbers, and you're done. So we get y squared over what? 4. Minus x squared over 5, yep, equals 1. There's your equation. Okay, any questions on that? All right, that's another one that's kind of the same as what we've been doing. All right, so this is the chart that if you want to copy something onto your reference sheet, it's the chart that takes into account shifting it. So the only difference is now you have an HK in the top. And your asymptotes still have the same slope. Okay? When it's vertical, the slope is still A over B. But you have a little bit more next to it. Y minus K, X minus H. You don't have to memorize this. All you have to do is find A, B, C, H, K, and fill into these formulas. That's it. So let's just practice one where we have to find all 5 letters, and then we'll plug them into each formula one at a time. Now, notice how they write this. They wrote b squared equals c squared minus a squared. That's not how I've been writing it. What I've been writing is the same thing. I just like to rearrange it so it's like this. Because I think if you remember the Pythagorean theorem, you'll remember it better. So I don't write it that way. But it's the same thing. Okay. So just ignore that. Do it the way we've been doing it. All right, so let's finish up with this one and see if we can find at least HKABC. What's H?
1.
Yeah, it's the 1. What's K? -2. A, the distance from the center to the vertex.
3.
They both have -2, so you can ignore that. Those are the same. What's the difference between 1 and 3? 2. What other letter can I find directly here? C, center to focus. Center to focus, 3. How do I find B? Use the formula that looks like the Pythagorean theorem. C squared equals A squared plus B squared. And again, this number pops up. B is the square root of 5.
If that's not the Pythagorean theorem, Hager, what is it?
The hyperbola formula. Now, which way does this parabola open? Do the branches open like this, or do they open like that? How do we know it's horizontal?
Because the first coordinates.
Yeah, look at your coordinate. Your focus is right 4, down 2. Your vertex is left 3, down 2. They're both down 2, so they're going to line up horizontal, which means which letter would be positive, X or Y? X. So now, I'm going to stop here, but you would take those 5 points, those 5 numbers, and you would plug them into what I just put a box around. That'll find your focus, that'll find your vertices, the last one gives you your equation. Just make sure you plug the right letter in the right spot. That's all. Okay? Okay, so if you want to try to finish that up, we can go over the answer to this one tomorrow, okay, before we go over the homework. Okay, just make sure you have these written down so we don't have to do this again. Homework tonight, kind of like it's been the past couple nights. The first part, a little bit of matching, 13 to 16 all. And then the rest is just odds. 17 to 21. 29, 31, and 37 to 41 is also odds. Don't forget, I will be after school for extra help tomorrow, if anybody needs to stop by.